so we're going to look at another three-dimensional shape and find its volume and surface area. And in this case, we're going to talk about spheres. Okay, so we've looked at other shapes where the basis of those shapes was a polygon. We've talked about pyramids, and we've talked about prisms, where we use things like rectangles and triangles and other larger polygons like pentagons and hexagons. And so now we're going to focus on kind of the analogy of now what happens if we go from an area problem which has got 2 dimensions when we're talking about a circle to now 3 dimensions, and we're talking about what's called a sphere. So a sphere is the equivalent of a circle, but in 3-dimensional space. So it's still got a center, it will still have a radius and a diameter, it will still have a circumference, okay, and then in this case we'll be able to now measure its surface area and volume. So these definitions here are kind of getting into the details that a sphere is essentially a circle in 3-dimensional space. We're measuring all of the points that are equidistant from some point called the center, but now instead of just being able to go like left and right and up and down, we're also going to be able to go to this 3rd dimension and talk about how tall it is. Okay, so the radius is still the measure of the distance between that center point and any point on the sphere. The diameter is still the measure of the line segment that goes through the center and has both of its endpoints on the sphere. So again, that's all very much just like a circle. So you can see down here we have a picture of what we're talking about. So when we're talking about the radius, it's actually going to be easiest to measure a circle that goes kind of right through the center of the circle. This is called the great circle of the sphere. So we're going to use that to find its radius. So it'll take a little while to get used to staring at the picture and finding the radius. But let's get right into the formulas that we're going to need to do this. So there's 2 of them. Okay, if we want to measure the surface area, which again measures the outside of the sphere, if we wanted to like paint the outside of the sphere, we would use the surface area formula, which is just 4 pi r squared. If you notice, the pi r squared kind of sounds a lot like our area formula for a circle, so there's your relationship showing up again. And then the volume of a sphere is 4/3 pi r cubed. Remember, when we're measuring inside of a shape, we're measuring using 3 dimensions, so that cubed, again, also makes sense, because we're actually physically going to be putting little 1-unit cubes inside of the sphere to measure its volume. Okay, so let's get into a problem using these formulas, and we'll do a surface area problem, and we will do kind of other related problems. So the first one, very straightforward. What is the surface area of the cube? And it asks us to leave our answer in terms of pi, which again we solved when we did things like area and circumference in circles. Okay, and so when it says what is it in terms of pi, so again we're going to go back to our formula, 4 pi r squared. So I'm going to start off with that formula. 4 pi r squared is surface area. Okay, and then I'm looking at this. This is a diameter, because again the dotted line goes from this edge of the sphere through the center to the other edge of the sphere. So I'm going to use a 5 as my radius, and we're going to say the surface area is 4 pi times 5 squared. Well, 5 squared is 25. I can multiply the 25 times the 4 and get a 100. And again, we're going to leave the pi in our problem. We will not multiply by 3.14. So we'll say 100 pi. Okay, and then it says meters here, so since we're still measuring an area, we're going to call it square meters, and we'd say the surface area is 100 pi meters squared, right? So your second problem here, exactly the same. Okay, so let's move down to this 3rd one. Okay, and so it's a little bit different now. They're saying in this 3rd problem, what is the surface area of the sphere in terms of pi? So exactly the same. So before we even look at the picture, let's write down that the surface area is 4 pi r squared. Okay. So now I'm going to come over here, and it looks like instead of us giving us the diameter or the radius of that circle that's going through the middle, again, this is called the great circle of the pyramid. It's the largest circumference circle in the entire sphere. Okay, so they're giving us the area of that circle instead. So when I'm looking at this, the area of a circle is just regular old pi r squared, right, when we were doing 2-dimensional shapes. And so it looks like, obviously the pi is the pi, and this r squared is the 49. So if r squared equals 49, then that means that my r would have to be the square root of 49, which is 7. Okay, so you have to work backwards in this case to figure out your own r is 7, and now I can plug in. It looks like it's going to be 4 times pi times 7 squared. Okay, and so then I just have to do 49 times 4. Okay, 49 times 4 is 196, and so I'll be able to say that the surface area is 196 pi, right? And so I can do the same thing with circumference. If it says the surface area, what is the surface area of the ball? If the circumference is 25, well, we know that the circumference of a circle is pi times diameter, and so that means that the, in this case, the 25, if that's the circumference, okay, we're going to say that the circumference is pi d, and then we can work our way backwards and say if I divide both sides by pi, that the diameter in this case is actually 25 divided by pi, right? So in this case, they did not specify to leave our answer in terms of pi, so I'm going to go to my calculator and type in 25 divided by pi, and it's going to give me an answer of about 7.96. So we're going to say the diameter of this circle is 7.96, okay? If I cut that in half now, okay, divided by 2, we get about 3.96, 3.98 we'll say, okay? So that means that if I cut this in half, that the radius is 3.98, okay? And now I can plug into my formula and say, now that I know all this, surface area for spheres is 4 pi r squared. My r is 3.98, so I'll say 4 times pi times 3.98 squared. And again, because they didn't specify to leave our answer in terms of pi, we'll actually go to our calculator and do 3.98 squared. Okay, 3.98 squared is about 15.84. And then I'm going to multiply that by 4. Okay, and then I'm going to multiply that by pi, and I get about 199. Okay, so we'll say the surface area of this sphere, okay, is about, okay, 199. Again, in this case, inches, okay, is my units, so inches squared or square inches. Okay, so you can see there's a lot of variation, not just using the formula, but we could be given an area or given a circumference and be asked to work backwards and find the radius ourselves to use for the formula. Okay, so volume, very similarly, it's just another formula, so we'll just do the one on the left here, because the one on the right is almost entirely identical. It says in terms of pi, so we'll just note that. So the volume for cubes is 4/3 pi r cubed, and r in this case, they are giving that directly to us, is 6, so we'll say 4/3 pi times 6 cubed. Well, 6 cubed is 6 times 6 times 6, which is 216. Okay, so I have to do really 4/3 of 16. Okay, I'm sorry, of 216. Okay, and so let's see what that is. So if I do 216 times 4, get that answer divided by 3, I get 288. So we'll say in this case the volume is 288 pi meters. Now we're talking about volume, so we're going to say cubed. Okay, so we're use cubic meters because we're talking about volume. Okay, so let's wrap up. I got one more problem for you. Okay, if they give us the volume, we can then find the surface area and vice versa, because both of these formulas are formulas. Again, let's go back and look at them. Okay, they're both formulas that use r. Okay, everything else is very standard, and that means that if I know the surface area, I can work backwards and find the radius, or if I know the volume, I can work backwards and find the radius. Okay, and so we're going to do that in these last problems. We'll just do one of them, and we'll be able to find, obviously be able to do the other. So if they tell us that the volume of a sphere is 5,000, I'm going to say, well, that means that 5,000 equals, and then I'm just going to use the volume formula, 4/3 pi r cubed. Okay, so now if I want to find the volume, I'm going to have to kind of get r alone. I'm sorry, if I want to find the surface area, I need to know r, because then I can just take that r, plug it into surface area, and I'm good to go. So I need to work backwards and get this equation now that we just set up to just be r equals. So we'll do this in a couple of steps. The first thing we're going to do is get rid of this 4/3. If you don't remember how to get rid of fractions, we're just going to multiply it by its reciprocal. Okay, 4/3 times 3/4 is just 1, which for us effectively makes that just cancel. So I'm going to multiply both sides by 3/4. So we'll start off with 5,000 times 3/4. Okay, 5,000 times 3 divided by 4 equals 3,750. Okay, so 3/4 of 5,000 is 3,750. On the left-hand side, the 4/3 and the 3/4 cancel. So now it says pi r cubed. It did say in our problem to round to the nearest square meter, so we can divide by pi. Right, so this says pi times r cubed. So now I'm going to take my 3,750 and I'm going to divide it by pi. Okay, and I get about 1193. We'll round to the nearest whole number and say 1194. So when I divide both sides by pi, I now have 1194 equals r cubed. And then to get rid of a a cube, we're going to do its opposite, which is cube rooting. Okay, so when I cube root 1193.7 or 1194, we get about 10.6. So I'm going to say when I cube root both sides, that means that r is about 10.6. Right? So now that I have my r, I can go and do my surface area formula, which says that the surface area is equal to 4 pi. R squared would usually go here, but we just found out that our r is 10.6, so it's times 10.6 squared. All right, so again, now after this, it's just right back to the calculator. 10.6 squared, okay, is about 112.36 times 4 times pi. Okay, and our final answer comes out to be about 1,412, rounded to the nearest whole number. So we'll say surface area is 1,412, and again, my units are in meters, so I'll say meters squared, right? So we can work backwards through one formula to get a radius and use that answer to find the use that r value to find the surface area of the other.